You guys see this? I've actually gotten tan. I think I've been out in the sun for too long. Luckily, today we're talking about shade. Earth. So Shader Graph is Unity's new node-based shader editor. It allows you to create all kinds of cool effects and generally just alter the visual appearance of your game. Shader Graph is a huge tool and can be used to create anything from flowing lava to holograms to sprite animations and post-processing effects. So far, all this stuff has been done by writing custom shaders by hand, but with Shader Graph we can do everything visually and in a fraction of the time. For someone like me who's just terrible at writing shaders, Shader Graph is an amazing tool, and I don't think I've ever been this excited about a Unity feature. Alright, enough talking about it, let's start using it. But first, this video is sponsored by Bolt. Bolt is an awesome visual scripting tool that allows you to quickly and easily program from within the Unity editor without writing a single line of code. The cool thing is that Bolt works in much the same way as Shader Graph. It's a completely node-based visual tool. However, instead of just creating shaders, Bolt opens up the full power of C# scripting in Unity, along with the ability to live edit your graphs while in play mode. Personally, I'm extremely impressed with this tool, as I think it combines the best of what I've seen from other visual scripting solutions. To get started, simply click the link in the description and download Bolt from the Unity Asset Store. Alright, it's shader time. So the first thing that we want to do is make sure we're using Unity 2018.1 or later. I'm using Unity Hub, so for me that means going to installs. And as you can see, I'm currently using 2018.1.1. We'll then create a new project. And here under template, we need to change to the lightweight render pipeline. Shader Graph is currently only available using this template, but support for other templates is coming. Now I've gone ahead and created a quick example scene. The only things that I have is a camera, a couple of lights, a tiny bit of post-processing, and of course this monkey. And as with any object in our game, this monkey has a material. The material is currently just using the standard shader. So let's change this by creating our own custom shader. We're going to be creating a cool glowy shader that looks like this. But first it's a good idea to make sure we're using the newest version of Shader Graph. To do that, we'll go to Window and open up the new Package Manager. Here we can see all the different packages currently in our project. You'll notice that the Shader Graph package isn't actually in here, but that's because it's part of the render pipeline's lightweight. In my case, this also has an update available, so I'm just going to go ahead and update it. So now we're on the newest version of Shader Graph, and we're ready to go ahead and create our shader. Let's right click in our project, go create, under shader, and here we can see the normal shaders, as well as 3 new options ending with graph. Let's select the PBR graph. We'll give the shader a name. I'm going to call it monkey underscore shader. And now to open this up in Shader Graph, we simply double click it. And this entirely new window is going to pop up. As with any other window in Unity, we can dock this anywhere we want or maximize and minimize it. I normally have this in full screen on my secondary monitor, but for now I'm just going to make it into a window and maximize that window. And by default, when we open Shader Graph, we have only one node. This is our PBR master node. Master nodes in Shader Graph represent our final output. Right away you will notice that you know most of these settings from the normal standard shader. We can change the albedo. I'm going to go ahead and make it some kind of blue here. That's a slot for normal, emission, metallic, and all that good stuff. And the cool thing is that instead of just controlling these through textures, we can now control them using different nodes. So in order to try and make our object glow around the edges, we need to modify our emission. However, if we just go ahead and change our emission for the entire object, well, we can see that the result isn't particularly interesting. Instead, let's go ahead and create our own node. By the way, to move around, you can use Alt and click or just the middle mouse button, and you can scroll to zoom. So to create a new node, we can either right click, go create node, or simply use the keyboard shortcut, which is space. This brings up a tiny panel where we have different categories for different nodes, and you'll quickly see just how many different nodes are actually in here. And on top of that, new nodes are constantly being added. So it's safe to say that we won't be going over all the nodes in this tutorial. So the node that we want to create here is what we refer to as Fresnel. So I'm just going to go ahead and search for that. And you can see it pops up. Let's click it, and voila, we've created a Fresnel effect node. Now understanding how the different nodes in Shader Graph work can be extremely math heavy. Luckily, we can always see a visual representation of what the node is doing. So in terms of the Fresnel effect, it's creating this circular ramp, and we can control the power of that ramp using this value here. For now, I'm just going to set it to something like 3. We then take the output of this node and drag it right into the emission input of our master node. And right away we can see that we get this glowing effect. So next let's add a way to control the color of our Fresnel. To do this, we need a color node. So let's hit space. Let's search for color and hit enter. Now this is a really simple node. It doesn't take in any inputs. Instead, we can just select a color. I'm going to choose some kind of bright orange. And we want to combine this with our Fresnel effect. To do that, we create another node. So let's hit space. And this time we want to create a multiply node. This of course allows us to multiply together two different inputs and get a result. So let's remove the old connection here by selecting it and hitting delete. And let's instead connect our Fresnel out with the first multiply input and the output of our color with the second multiply input. And right away we can see the result. We can then take the output of this multiply node and put it into emission. And voila, we can now use the color field to control the color of our Fresnel. So this is a really cool example of how this node-based way of thinking works. You combine together different nodes in order to create interesting results. And pretty much all nodes work this way. There's some kind of input, in our case the Fresnel and color. The node does some magical processing behind the scenes and spits out a result. And if you ever wonder what a node does, you can always right-click on it and hit Open Documentation. And this will open up a documentation page for that particular node with a description of what it does, which kinds of input and output it has, as well as the function that it executes behind the scenes. So that's really cool. Now there's definitely some more we can do with this. I'm going to change the color mode from default to HDR because we are working with emission here. And so I'm going to go in and bump up the intensity to say 1, just to make the glow a bit stronger. And of course, if we save this asset now and go back into Unity, we can easily apply it to our monkey. All we need to do is select our monkey material, and under the shader, we'll go under graphs. Currently, all shaders created with shader graphs go under here, but I hear the team is currently working to fix that. And we can then select our monkey shader, and we can see just how cool that looks in the editor. However, something that would be really neat is the ability to change the color of our Fresnel from inside the material. Because currently we have to double click on our shader, open it up in shader graph, find the correct node and make the change in here. And that's not very intuitive. And also it means that the color will be the same for all of our materials. Instead, we can right click on this color and we can convert it to a property. This makes it so that we can no longer edit the node in here, but instead it shows up in the top left corner. This is what we refer to as the blackboard. And here we can see all the properties that our shader has. In our case, we just created a color, and if we expand this, we can now see that we can change both the color and mode up here instead. We can also right click on it to rename it, and I'm going to rename it to Fresnel color. As a result of this, if we save this asset and select the material, we now change the Fresnel color in here. Awesome! Let's see what else we could do to make this more interesting. First of all, we can change the preview down here so that we can see it on our monkey head. To do that, let's right click and choose custom mesh. And we can then select the monkey head. That makes everything a bit clearer to see. We could then try animating our Fresnel effect over time. To do this, let's select all of our nodes and move them up a bit. Let's then create a new node. This time I'm going to search for time. Let's hit enter. And here we have all kinds of different outputs for time. Let's then create a multiply node. So space, multiply. I'm going to delete the old connection here and go from our old multiply node to our new one. And from our time node, I'm going to take the sign of time and drag that into the second multiply input. And we can see now this cool animation that occurs. Of course, the sign of time goes between -1 and 1, and we really only want it to go between 0 and 1. So we can actually remove this here and instead put a node in between. So we'll go from sign of time into, and we'll then create a remap node, and we want it to go to the input. So it's going from the sign of time to the input of our remap node. Our input goes between -1 and 1, and our output goes between 0 and 1. So now you can see that the animation looks much nicer. Let's then take the output of our remap node and drag it into the second input of our multiply. And finally, let's take the output of our multiply node and drag it back into emission. And there we go, we've now created an animated material. I don't want this effect to completely disappear at any point, so I'm going to make it go between 0.2 and 1 instead of 0 and 1. I think that looks a bit better. So we've now created a pulsating highlight. Let's just clean up our nodes here by moving them up a bit. Let's save the asset, close down shader graph, and hit play. We can see that our monkey is indeed animating. Woohoo! Now, the final thing that I think is good to know when getting started with shader graph is how we can work with textures. To do this, let's start by creating a property in our Blackboard. Here we have some different ones to choose from. We're going to select texture, and let's just create an occlusion texture for our model. So let's call this occlusion. And as the default input here, I'm going to select a monkey occlusion texture that I have prepared. We then take our property and drag it in here. And at this point, it would be pretty intuitive to simply go from the occlusion property into the occlusion input on our PBR master. But as you can see, it really doesn't accept this. The reason why is that there are currently two different types. As you can see on our PBR master, after occlusion, there is a 1 in parentheses. That's because the occlusion is a single channel value, whereas our property is parentheses t. That's because the type of our property is a texture. So to convert between these, we take the output of our property, we input it into a sample texture node, and we then go from this sample texture node into the occlusion input. And now it should work just fine. If we save this asset and select our monkey material, we now have an empty texture slot. Here we can then input our monkey occlusion. And as you can see, if we toggle between the two, it clearly adds some nice ambient occlusion to our model. So that's how you can apply texture nodes in shader graph. And that should be enough to get you started. From here on, it's just about playing around with it, trying to recreate different effects and figuring out what the different nodes do. And most importantly, make sure to have fun. So that's pretty much it for this video. However, shader graph is a huge tool and there's so much more exciting stuff to cover. If you'd like to see more videos on shader graph or on how to create cool effects like holograms or dissolving effects, definitely let me know in the comments. I'm really fond of the tool so far, but there's still a lot of stuff that I would like to see added, like
All right, welcome back, everybody. Last day before we get going in the final project, and you guys get to unleash your creativity. But let's see. For today, we are going to be doing some stuff with shader graph. Not what Brackeys just did. We're actually going to make like a little laser effect that you could use in your tower defense if you wanted. But the first order of business actually is going to be voting or ranking the final project proposals. It is too hot. My office is so hot in here. I had an ice pack on me like just before this class started. Okay. So here's what we're going to do. Hopefully you guys have all reviewed the final project proposals. If you have not, I'm going to put the link handy in the Zoom chat. So that's for the proposals. And when you feel like you're ready to rank these, I'm gonna give you another link here where you should be able to drag and drop how much you prefer one project over another, right? We're really trying to narrow down the projects we have to just 7. And I guess to add, why again the number 7? It's just that when we're working on these projects, you're going to have different milestones, and I need to be able to work with each group. And getting past 7, there's almost like not enough class time to have that kind of back and forth. So that's kind of what I'm going to go for your class, and we'll see how it goes. So voter link. I'm going to put this into the Zoom chat. Please put your name and your email in there. This is good just so I can verify that you're a real person, part of the class, you're not voting twice and all that. And if I'm lucky, we'll actually be able to use the information from this to sort you into teams, but I'm not really sure what this is going to give us. So here comes the link. All right, so take the next 10 minutes to do that. We'll meet back in here at 6:25. All right. How do we do here? Anyone need any more time? ET, yeah, I know. That's a shoe in. Let's get this over here. Ranked vote results. I will give you all the result link here. And let's see, actually, can I close this down? Results visualization. I don't need a visualization. Just give me, I need to close this down. I'm not sure how this works. Results. No end date. About, oh, here we go. Close election. Let's view. Round one. I don't want to see this. Just show me the results. 5 winners. I told you 7 winners. Okay, 1, 2, 3, 4, 5, 6, 7. All right. So here's what I'm seeing as our winners. At the end, did you see something else I don't see? Oh, these are all the rounds. Okay, I see. Gotcha. All right. So here's, we got Conquer the Riviera, the Metroidvania game, the Negative Space Puzzle, Star Fox game, the Slayer, Bubble Sort, Mini Game Arcade, and Diet Smash. All right. So one of the ways this is going to work is that if you don't want to remain anonymous, you're going to have privilege. The privilege you're going to get is you're guaranteed to be on that team, and you are allowed to, you're going to get a first round draft of anyone you would like to be on your team, right? So you own that game, and if anyone is, your friend or your partner, someone you work well with, you're allowed to choose them to come into your game. And if there's still room to take on other people after that, then we'll have more of a lottery system, I think, to get people in. All right. Okay, so those of you guys that came up with those, pick Danny. Yeah, sure. Can I be on a team? Between now and Tuesday, feel free to talk to your classmates or anyone that you'd like to have in your team and get that started. And on Tuesday, we are going to do a formal team formation, get everyone on a team, and we're going to get together and write up a real game design document. And that will be due on Thursday. So any questions before we move on to today's lesson? Okay. So let's move on to something I was playing with. Okay. All right. So here are some demo lasers I was playing with, and to get started, I put a package up on Canvas. There is a laser textures pack. Go ahead and download that, and you'll have all the images that I'm using here. And you can see this one's just kind of, it's grayscale. It's not being colored. This is the fire, kind of wavy fire thing going on, and then these are a little bit more wavy laser-like. And we are using a shader graph to accomplish this. The magic really is that we are using a single texture, and we're scrolling that texture to make it look like it's going in a particular direction. And on top of that, I am perturbing the texture coordinates so that it gets this wavy effect, right? If I came over here and I wanted to take out that distortion effect, right? This is what we're going to work on first, is just making this texture move. Actually, really, this is first what we're going to do. We're going to get a texture on a quad or on a line, we are going to make it move, and we'll perturb it a bit, right? So you can get some sort of distortion effects going on here. All right. So to start off with here, you'll need those textures. And the second thing is that we're going to need to get shader graph. The video we saw in the beginning said that shader graph needed some other kind of rendering thing. That's no longer true. We can simply go Window, Package Manager. We'll need to have the filter drop down here set to Unity Registry. And once this comes up, I will just search for it. So shader graph, right? So you'll just select that, hit the install button, and we should be ready to go. I'll give you guys a hot second to do that. Something to maybe play with on your own later if you like is that oftentimes when you get a package installed, there will be a sample section here where you could import some other interesting bits related to that package. Okay. All right. So let's see, what do I want to do? I will make a new scene. Default is fine. Create that. Okay. So first, I would like a quad to put things on top of, and I guess we don't really need Pro Builder here. I could use it, but don't need it. I'm going to just say create 3D object, a quad. Oops, zoom up on this. And maybe that's a fine place to start, right? I'll just be looking at my quad. Nothing special is going on. What I would like to do is create a shader that just simply holds a texture, right? And obviously we don't have to go through the trouble of making a shader do this, right? Any material will do that. But to have some special logic for the laser effects, we do want the shader for that. So what I'd like you guys to do is, make yourself a new material. Actually, I take it back. Don't make a new material. Do this instead. Right-click in the project and go to Create. Then you're going to go to Shader Graph, Built in, and, well, I think Unlit is fine, actually. And just do Unlit Shader Graph. So I'll leave this on the screen for a few seconds. So we're going to do shader graph down here. I'll just say this is a class laser shader. And you should get an icon that looks like this, I don't know, this weird blue box thing. Just double click that. And when you do, you're going to get this new window, right? Just like the video showed, but this is 4 years newer than that video. So there's some newer, bigger, faster, stronger things about it. We're going to be doing some very simple things here, right? You can see that there's these two boxes. These are our outputs, right? So at the end of the day, we have to feed a color for every pixel in this object. And at the end of the day, we have to feed a position, normal, tangent vector for a vertex. And these are akin to the vertex shader and the fragment shader, right? They're kind of just mapped here together. And if we don't put anything here, it's just going to do the right thing for us. So it's not like we have to have something there, but if we want to do something, we can. So to start off with, I'm going to do nothing at all fancy here. I'm looking at this. If we ever want to see our changes, we have to click the Save Asset button. I don't think, just Control S do it. No, Control S does not do it. You have to click this button for whatever reason. So that's going to be our shader. It's our new shader. We can automatically make a material for that shader by right-clicking on the shader itself in the project. Right-click, create material, right there. And if you do this while having the shader selected, it should automatically create you a material with that name. And not only with that name, but you'll see if with this material selected, you can see that it's using our shader, right? So there's no properties really here because we haven't really done anything, but we're just setting it up. So, okay, we have a shader that does nothing. Let's take that material with the shader that we made and drag it on here. And you can see, okay, gray square. Not very interesting. The first order of business is to simply get a texture showing on our quad. So we're going to do that editing inside of our shader. We're going to say, okay, shader, I would like to create a property where a user could say what texture they want. Right, so we go to this thing over here. This is where all of the inspector properties for this material are going to pop up. Right, currently we have none. If we go to the plus, we are just going to look for texture 2D. You'll put this on here. I don't know. I'll call this main texture, I guess. That's fine. If we hit save as now, and then you go to look at your material, I have it selected here in the project, you should see that we now have the property main texture and a slot for us to actually assign a texture. So go ahead and assign whatever you want to that. And I'm going to take a pause here and see who needs help. So I'll put the flame texture in there. Not save. We're good. It's there. Where are you guys at? Talk to me. Send the flame texture in chat. It's on Canvas actually. So if you go to the module, there's this laser textures.unity package. Just import that and you'll have it. No problem. Any other questions? Give me a thumbs up if you're ready to keep going. Okay, whoever put the red X, is there anything I can do to help you out?
I'm not sure how you got that window open.
The shader graph window? So after we created our shader graph, all you have to do is double click on it. I think mine was just docked here. Yours might have been floating, right? Like if I close this and I come down here and I double click. Oh, I don't know. I guess mine puts it there. Some nice things inside of the shader graph window, right? We can move these windows around. You get a little preview. You can middle mouse to kind of get around this. You can zoom in and out with the mouse wheel. It'll zoom in or out around wherever your mouse is.
I'm trying to find it real quick, but how did you make the shader graph?
Shader graph, you need to have installed it first. Did you do that in the package manager?
Likely not.
Okay, that's step one. So you're going to install that. You'll right click in the project, go to create shader graph, built in, and we're going to do unlit.
Got it.
Okay, and that makes you this thing. You double click that. Okay. full screen, the shortcut in Unity is Shift Space. You can go to any window, like I am on the package manager, Shift Space. Now I got a lot of package manager. If I select class laser shader, Shift Space again, right? It's a handy shortcut. Okay, I would like to sample a texture. So the shader's going to run per vertex and per fragment, or per pixel, really, right? So we're going to pretty much ignore all the vertex stuff. We're really focused on what's happening for every pixel when it gets run here. Now, for every pixel, I would like to use whatever the texture coordinates happen to be at that spot to look up a color out of the texture, right? So I don't know what pixel we're on, and it doesn't matter, but I know I'm going to have to fish a color out of this texture. So I'm going to click and drag it out here. And we can't really just hook up a texture straight to here because that doesn't make sense, right? This texture is like, it's all of the texels in the texture. We just want to grab one of them. So the trick is in order to get a texture, those of you guys from 325 remember, yes, you need to have the texture, but you also need to have the texture coordinates. So if we can create a new node in here to get the texture coordinates by hitting space, and we could go to UV. I'm just going to type UV in the search. Let me do that again. UV, yeah, there we go. Hit enter, and if you get the UV coordinates, they should look like this, right? And you get this little preview of it. The UV coordinates look like this in the preview because 0, 0 would be black, 1, 0 would be red, 0, 1 would be green, 1, 1 would be yellow, right? It makes sense. So those are the two things we need. Great. Now I need to have a node where I can use these two things to actually get a single color. So I'm going to look for a different node for that. I'm going to look for sample texture 2D. Right. So I just type sample at the top, and I'm looking for that sample texture 2D. When you get that, you're going to get one of these. And we want to tell this node what the inputs are. I want to say, hey, I want you to look inside of this texture that I'm giving you right here, the one that the user specified in the material. I want you to get the color right at the spot that I have a UV coordinate for, right here. And it's going to give us a single color right here, RGBA, right? Red, green, blue, alpha. So at this point, we can take that output and simply feed it to our color. So you should see something like this. I'll leave this on the screen for a minute. Let's preview. Quad. Okay. Guess you can't really see much. All right. If you have this all hooked up, remember to hit Save Asset on the top left. I'm going to minimize this, Shift Space, and see what it looks like in the scene. Cool. At every point here, every pixel, we are grabbing the right color because we have a coordinate and we have the texture we're looking into to get the color at that coordinate. Another check-in. Who's stuck? Anything you guys want to see again? Anything you need help on? Looks like that, but the image is flipped. Why would the image be flipped? It could be because of the way you imported the texture. If I look at the flame texture, So any weird import stuff here. One thing you do want to say is I want to say that the alpha source comes from the black or white color, right? I think it defaults to this. There's no alpha channel in this texture, so I'm saying, hey, create an alpha channel, and I want you to use whatever the regular color is as an alpha value. All right, so make sure you do that. Hit apply if you need to. A cube, not a plane. Yeah, that'll do it. Okay. Great. So next up, this texture's, it's not quite right? Like, yeah, there's black, but I don't want the black to be there. I want that to be alpha, right? So our transparency is not working. We need to set that up. So I need to come back into our shader. And now we need to look at our graph settings. If you come over here to the graph inspector on the right, you'll see a whole bunch of different settings. We don't need to worry about too much here. Just keep going down. Underneath the built-in section, you're going to see surface type, right? It'll say opaque, and we don't want that. Say transparent. And after once you do set that transparent, notice that we now have an alpha value to play with right here. So that's cool. I'm just going to type in a number just to make sure it's working. I'm going to put 0.5 and see if we can see through our texture. So save, scene, looking good. Again, in graph settings, select transparent, tweak the alpha value. All right, so the thing is, I don't really want a constant alpha value, right? The thing that we're going for is I want the black areas to be the alpha part, right? So black being 0, that'll be completely transparent. So what we can do is we can go to where we got a color, right? We got a red, green, blue, and an alpha. Is now I can take the alpha from here and actually feed it to the alpha. So now we're going to get a per pixel value for alpha. Hit save. Go to the scene, and you should see something like this. All right, I'm going to give you a minute to catch up if you need it.
Sorry, I just got the transparent step done. What was the last part with getting rid of the alpha?
Well, we got a red, green, blue, and alpha from our texture, but all we were really using was red, green, and blue here in our color. We actually want to pass along the alpha as an output for transparency. So you just need to take your alpha and make sure it makes it all the way across into the alpha spot.
Gotcha. Thank you.
No problem. Okay, and let's keep it going here. Next thing I would like to do is, I think I would just like to scale this, right? So this is not going to be a very good laser if it's just a little square, right? I'd like to scale it out something like this. But the problem here is now that, the geometry is larger, but the texture coordinates didn't change, right? Texture coordinate here is still 0, 0. The texture coordinate in the top right is still 1, 1. And so what I'd like to do is account for that. So with it, make sure you stretch this out just so we can test it. Go back to the shader. And now what I'm going to do is, how do we want to do this? Well, okay, let's do it like this. What I'd like to do is take my UV coordinates and make sure that they're scaled also, right? So if I go back to my scene, let me put some numbers in here just so we have something to work with. Let's say I scale it by 4 exactly, right? So what I want to have happen is I don't want to go from 0, 0 to 1, 1. Instead, what I want to do is to go from 0, 0 to 4, 1, right? Because I didn't scale vertically, I just scaled horizontally. And when you have a texture coordinate bigger than 1, you know, what happens? You guys remember? What usually happens anyway? It repeats. You guys know this. Yeah. Yeah, it's like tiling. And the reason it's tiling is that imagine that, let's just look at the horizontal, right? This is 0, that's 1. If I made this 4, or let's say I made this 2, that would mean halfway right here is 1. And if halfway was 1, it means you get the full image right here 1, and then you get it repeating a second time because it's going past 1 to 2. You know, after you go past 1, it just keeps wrapping back over, you know, 0 to 1, 0 to 1, and so on. And so I want to capture that in our texture coordinates. So what I'm going to do is I would like to multiply our UV coordinates. So if I drag out here, I can say multiply. And actually, let me not do it that way yet. I'm just going to create a new multiply node. I'll hit space, type multiply. I want one of these. I'm going to take my UV coordinates, and I want to multiply them by whatever my scale happens to be. So we need a node to get the scale. So what's our scale? It's telling me that it's here in this object, and sure enough, that's good. So I'm going to take scale from object, and now I've got scaled UV coordinates. But I'm still not using them, right? I need to actually say, hey, don't use the UV coordinates directly because the output of UV is going directly into sampling the texture. I want to instead say, hey, let me massage these coordinates first by multiplying them, and then here, use the result right there instead. So if I save that and then look back, you can see it tiles, right? We're actually going, you know, 1, 2, 3, 4. All right. Now, these shader graphs can get very messy and very ugly. And I think, in my opinion, they can be harder to read than code if you don't take extra care with them. So one of the ways we can make this nice on ourselves is we can say, hey, I don't want to have to stare at all these nodes. Instead, I want it to just group these in a way that I can look at a comment and say, hey, let me just read the comment, you know, to understand what this is doing. So to make that happen, I'm going to drag select all these nodes. I will right click anywhere on them, right click right here. I'm going to say group selection, and I'm going to say get color from the texture. Boom. And now really, I would not want to even look at these nodes, right? I want to read this and be like, okay, cool. I understand what that block is looking at, and now I don't have to sit there and get into the minutia. All right, so the next step that I would like to do is I'd like to make the texture scroll. And you guys can always stop me if we need to back up and go over a step again. So this is what we currently have. I would like to make, what I want to make is the texture to move in one direction, like horizontal, left or right. All right, so what I'm going to do is essentially we just need to add a U value to our texture coordinate, right? So instead of this being 0, 0, you keep adding to it, and that 0, 0 keeps moving along here, right? And then because this is now 0, 0, this is a negative number, and it's just kind of smoothly going in one direction. So, all right, this gets, that gets the color from the texture, but we need to kind of pull this out a little bit. I want to say, instead of just using the UV coordinate, I want to add a little bit to the U coordinate, right? So this is a, it's shown as a 3 vector. We only care about the first 2. I would like to say, let's play with it a little bit. Let's say add, or let's add an add node, right? I'll hit space, type in add, put that in here, and now I'll say, okay, I want to add what our scaled texture coordinates were. I want to add to that some other value, right? And let me finish hooking this up over here. I'm just going to type something in here so you can see the effect. Let's do this. Let's see if I can even notice if I put 0.5 in here. I hit save, go back. Oh, not like that. I can't even notice. We're going to have to do another trick to make this work. When to use add versus when to use multiply. I think you really have to understand the concept of what it is you're doing. Like the idea of a multiply right here with your UV coordinates is we know that UV coordinates go from 0 to 1. And if I want to go, instead of from 0 to 1, I want to go from 0 to 3, and my scale's 3, right? And then you can just multiply it. That's the idea. If we're scaled by 3, well, then I want, if this is going from 0 in the x to 3 in the x, well, I want my UV coordinate to also go from 0 in the u to 3 in the u, right? So we're matching in that case. The reason I'm going to add here is because we're adding an offset to what we already have. We're just going to nudge it. But to visualize this better, what I'm going to do is make another property. I'll say, let's do this. This will just be temporary. I'll just call this temp float. I'm going to take this float. I'm going to drag it in here. Actually, you know what? Let me make this a 2D vector, not a float. Vector 2, because I want to be able to choose how I'm offsetting in the U or the V. I'll call it temp. Let's bring this down. Put that in there. And now it's not going to do anything, but I just put it there because I want to illustrate something. Here's what we have. Let's look in the material now, right? In the material we have, okay, there's our texture. Here's that temp vector 2. But watch what happens when I add, I increase the value of the U, right? This is what we're adding. Every time we're adding this, so it's like if we add a little bit more than what we had before, it's going to look like it's moving in a particular direction. In this case, right, you probably want our laser going this way, so you'd actually have to be subtracting. But that was just a demonstration. Let me show you what we actually want to do here. Instead of let me make this big again. Instead of just the temp value, I'd like to use the value of time. So this is always moving, right? So what I'll do is we'll add a time node in here. Space, time, kind of like the video did. In this case, I just want the time to flow in some direction toward on the U only, right? So I would like to create a vector 2 that just sits in here where time just only goes into the X component, right? Because that's going to essentially be our U. And now if I put that in there, you should see, okay, time is making the U coordinate always go forward. Like that. If you don't see this happening on your side, it could be because your scene view is not always refreshing. You have to go up to this checkbox and tell it to, like, here's what yours probably looks like, right? It's like, hey, it's like you saw it move for a second, but then it's not really moving. We need to come up here and hit always refresh. I'm sure I lost a lot of you there, so let's maybe I'll tease this apart maybe a little bit, see if I can clean it up. All right, so I want to get rid of this group. No, not the contents. Can I take everything out of the group? How does this go? Ungroup. Okay, select everything, ungroup it. Just delete this group. Okay. I think what I want to say is over here we'll say get a scrolling, a properly scaled scrolling texture coordinate. Right? That's what this is going to be. Get properly scaled scrolling texture coordinate. Like that. And I'm going to leave this on my screen for a little bit so you guys can copy it. All right. Next up, let's reflect on where we're at here. I'll just save this and see that. Well, it's not very lasery. It's just black or white. And part of the beauty of a black and white thing is it's very easy to make another color, right? Because if I multiply red by white, I get red. If I multiply blue by white, I get blue, and so on. So I'd like to give a property in our material that lets us choose what color we want this laser to be. So we're going to do this the same way we've been doing. We expose things to the inspector over here. Come in here and I'll say, look for a color. This will be laser color. And now we have to ask ourselves, okay, if I'm going to use this laser color and combine it with my texture color, should I use multiply or should I use add? What do you guys think? We get our color coming out here, and our black and white color coming out there, and our hand-picked color coming out here when we need to combine them. Yeah, it's definitely a multiply, right? Because if we have, what happens if you add red to white? I guess you have to ask yourself that question. So you guys tell me what happens there. If I say red plus white, we get not in math, you don't. Maybe on an artist palette that's what happens because that's subtractive color. There you go, Nikki, you got it right. 255 plus anything is still 255 in the eyes of your code, right? It does not matter. So additive isn't really going to get you anywhere, right? Once you're at white, there's no going any further. You're already hit the top. But in shaders, you could think of really the white as being 1.0 and black as being 0. So really it's kind of like, once you hit 1.0, you've already capped out. You can't turn it to another color by doing that. But if you multiply it by red, let me show you the math here. I'll write it out. Okay, so white is 1, 1, 1 times red, which is 1, 0, 0. And that equals, I think you guys can do the math. This is not a dot product. This is just component-wise multiplication. The x's multiply, the y's multiply. Yeah, right? So red times white is red. But your color will gets rid of the any parts that don't belong there. You know, if you multiply something by less than 0, that number is going to go down. So I'm going to drag around the kind of nicer way here that I haven't really showed you too much yet. Instead of hitting space to pick something, you can actually drag out from an output and then let go. And what this is going to do is, instead of hitting space, it brings this up, but it brings it up with a benefit, right? What I want is a multiply node, but it gives us some choices here, right? I can say multiply A or multiply B. And what that's really saying is, where do I want this output to go when it makes this? Do I want the output to go into the A portion on top, or do I want the output to go to the B portion on the bottom? Well, based on the way I'm setting this up, I think B would look nicer. You know, it doesn't really matter which one we pick. You can see here it is. My color goes into the B part of the multiply. I need to put the other color actually into the A portion. And now I have to cross my streams, which I don't really like. So maybe what I'll actually do is put this up here. It still wires. Now I got the wiring backwards. So maybe I'm going to undo this now. I'm going to say this goes to A, that goes to B, and that goes to color. There we go. Make it a little prettier. Okay, so now I got my laser color multiplied by white it should tint the color of the laser. I'll hit save. Go back to the scene. It's like shade from Hollow Knight. That's probably not what we're going for. So we can come over to laser color, choose whatever you want over here, and there's your tint. Okay, pretty cool. What I don't like is that it's going backwards. So we should probably find a way to customize that. I think what I'd like to control the speed at which this is moving too. All right. So what I can say is, let's introduce a new speed property here as well. Are you guys still following along, or have I lost everyone already? Let me see how many. Give me a thumbs up if you're still following. Oh wow! Okay, awesome. That's great. I guess you guys rock. Okay, let's add the new property in here. New property. We would like. Oh, thanks. Okay, what do we got here? We've got some time. Temp is doing something. Temp is doing nothing, actually. Am I not even using temp? Yeah, I'm not. I'm just going to get rid of it. I want to affect our time. I don't want our time to just positively increase here. I would like the ability to say, hey, time, go faster time, or go in reverse time and go faster in reverse. So we're going to make a vector. I guess all we need is a regular float, right? Unless we allow us to scroll the Y, but we can ignore that for now. I'm going to make a float and just call it speed. And we'll use speed. Do we use speed to multiply with time, or do we use speed to add with time? What do you guys think? Right. I mean, if we just add speed to time, it's just adding a constant value. You won't even notice it. You will have no idea that it's even happening. But if the time ticks like 1, 2, 3, 4, and I multiply it by 2, time is like 1, 2, 3, 4, right? Yeah, you still move at the same pace. Yeah, exactly. So I'm going to take this speed, bring it down here. Yeah, go in the group. And I'm going to say, all right, speed, you're going to multiply. You're going to go to the section. I don't care about this preview. Time needs to go to the A section. And let's rewire the output over here. So that should give us control of how time is marching. All right. Let's save that. Shift space. Come back here. Oh no, we froze time. That's okay. We can adjust the speed. Here's 1, but here's -1. And maybe that's too fast. Maybe we need like a fast laser, right? We'll just do it like that so it's easy for us to look at for right now. Do 100. All right, then. Whoa. Hey, wow. Actually, that's not what I expected. That's interesting. It like discretizes it. That's like a unintentionally cool effect. 8 to 10 looks lasery. Yeah, it's like even pixelating a little bit at that speed. I'll leave it at 1 just to keep a good eye on it. Or -1 rather. No, not that. Okay, so we've got control over the scrolling. It's going in a particular direction. You should be able to scale it. Let's like test that that's okay, right? Doesn't matter how far we scale it. It's adjusting just fine. Now, the more complicated part is actually thinking about how we want to distort the UV coordinates. And there's like so many different ways to do this. I'll try to give you the the simplest way possible. I'm going to make some room here. This box, we get a properly scaled scrolling texture coordinate. Great. The next box, I want to say, hey, I want to take that coordinate and just perturb it a little bit. All right, so how do we want to perturb it? I don't know. Let's say we just perturb the V, the vertical part using a sine wave, sine coordinate. So I'm going to get a sine node. No, I'm not. Wait. There's a sine node. And I just want to do this to the V portion, right? But what comes out of here right now, this is a 2D vector. And I can't just, if I do this, it's just going to use the X part of that. And I don't want it to do that. Instead, what I need to do is to split apart this 2D vector. And the way we do that, take a guess, is called split. And it says RGBA, right? There's no BA, but the XY are the same as the RG, and we can just, when you think red, you could think X, you could think U. Really, it's just trying to signify the first. Here's the first coordinate, and here's the second one. We'd like to do stuff with the second one. The problem with just putting it directly in here. I mean, I guess we could do that. That would do some weird stuff. 0 to 1. We have to think about math now. Our UV coordinates, they're getting scaled actually. So they'd be like, or the Y is still 0 to 1. But I guess we want to think, okay, whatever it is, we'd like to use something from the sine. And we have to have some input into the sine, which is, let's see, how do we do this in a less confusing way? I want to perturb this, right? So I'm going to definitely add something to that. Let's start to set it up, right? So I'm going to add something to our V coordinate. I don't know what it is yet, but it's going to perturb that coordinate a little bit. And once it's perturbed, I'm going to put it back into a vector 2, so it can be a texture coordinate again, right? I'm just taking out the V. I'm going to mess with it and then put it back here. I'll let the U go on unperturbed, and then I'll rehook this up. So let's move this over so you can see a little better. Stop. Okay. All right, I'm going to perturb this somehow. I think to start off with, I'm just going to perturb it with time, right? I'm going to feed time in here, and this will just make it wavy, but okay, let's see what we do. I'll drag this out, say time. And now based on what time is doing, I'm going to add plus or minus 1 to this. And this is not going to look good. So brace yourselves. Let's take a look. Yeah, see, so what sucks about this is that it's the same for the whole laser everywhere, and that's not what you want. I would like the sine function to be different based on how far we are along the horizontal. So I think what I'm going to do instead is not use time. We could use the x of the u coordinate. Whoa. Let's try it. So if I cross the streams, but so be it. Okay. Yeah, that's interesting. But it is doing what I want, just doing way too much of what I want. All right. It's like if you add plus or minus 1 in the texture coordinates, that's like the whole entire texture. When we perturb something, right? Usually the word perturb means to just slightly nudge it, and we're not, we're like doing the opposite of slightly nudging. I don't know. Someone give me a good metaphor because I don't have it, but we're doing a lot of something. We can't add -1 to 1. That's no bueno. So we're gonna have to tame what the sine function does. So the trick to do that is something called remap. I can create a node called remap. And I'd say, all right, so we don't need to look at this really. Should I put it up here? I'll leave it there for now. All right, so sine is going to give me something -1 to 1. It's going to change based on the u coordinate, which is a horizontal measure. And I'm going to put it into this remap. So -1 to 1 comes in, right? I'm telling it this second property here tells me what the range it's expecting to have on the value that comes in, -1 to 1. What's going to go out, though? I'm going to say out is going to be -0.1 to +0.1, right? This might actually be a big effect already. So that's my perturbation value. I'm going to feed that into my V here. Guess I can roll this up. Yeah, I'll give you a few seconds here to stare at this. It definitely needs some cleanup. Okay, so I'm going to save that asset, go back, look in the scene. Yeah, now you can see it moving, but it's like so low frequency. It's definitely not what we want. The frequency is way too low. So in order to increase the frequency, we have to multiply, right? This is starting to get kind of ugly. This is what do we want to do this here? So I'm going to say, I'm going to move stuff around, try and clean this up. I'm going to say this part is going to be the I'm gonna just select the nodes that we're working on right now. I'm gonna say group these. These are gonna be perturb v coordinate. So I got some room to play with here. Maybe kind of move this around to make some room. And I'm just gonna rearrange this to make it look a little less messy. This to go that one, and or this to split the G. Yeah. Okay. And what's going on over here? That's taking it straight over. Maybe this didn't really clean it up that much. No, I don't know. I can futz with that some other time. So, all right, what we got here is we got a sine wave. It's sine waves based on a horizontal, but it's too low frequency. I need to make sure that the thing that's the input to the sine function is a much bigger number, so it waves a lot more. All right, so I can take what's coming out of here, and I can multiply it by some number. I don't know. I'm gonna crank that to 10, because now you know what this is like. It's like this. Shader, no, math what is it called? Graph toy. It's like this thing right here, right? This is what I use all the time when I'm writing shaders. Here's sine of x. This is way too low frequency, but if I say sine of 2 times x, hey, now we're getting somewhere. Sine of 10 times x, this is a little bit more what I'm looking for. So there's 10. I'll save, and maybe I'll do a better job of playing with wires later, but let's see what it looks like. Okay, so it definitely made it up. But I think one thing that I don't like is that the sine wave moves at exactly the same speed as the texture scrolls. This would look way cooler if the waviness moved at a different speed through this instead of being exactly moved with the texture, right? I don't really like that. So we need to probably not just use this u coordinate. U multiplied by 10 times sine. There's probably a much easier way I could have done this, but I'm going to roll with this right now. I'll show you the other implementation here in a bit. I'm gonna add time into this just to mess with it. So if I add time, and I'm going to put this in there first, and then hook that up. Just want to see what changing the speed it will do. So yeah, see, that looks a bit more interesting. And truth be told, I wouldn't really want to use a sine curve to do this. I was actually I brought sine in thinking that would simplify this process, but I don't think I've landed on a good simple way to explain this just yet. Let me show you something that would be better than this. And yeah, just follow, just watch me for a minute here. Does this have it? I think this should have it, right? So sine is great, but it's too regular. It's too patterned. I would like something that is smooth in its curve like sine, but not this predictable repeating pattern, right? And so to do that, we have something called noise. So if I No, look, that comes up there. I can just type noise X, right? Like this is actually more what I'm looking for. If I multiply this by 10, great. That's what I'm looking for. That's what I want. And I'm not going to try to smush that into what we have right here, but I am going to show you the shader graph that I made for the other stuff I was working on. So let's actually, but before I cut to that, I'm going to show you the shader in case you want to copy it, copy what this looks like. So this perturb, and I don't know, something like that. And this final bit is get the texture, color, and tint it. Yeah, there we go. So those are my 3 pieces. I'll leave this up here for you guys to copy that if you like. Does anyone need to see other parts of the graph? Okay, well, I'm going to save this and let's look at a slightly different way of doing this. I go to sample scene. Yeah, okay, save this. Sample scene, all right. So this is a different one, and this one actually does use noise. So you can see that when we look at these, right, it's like more kind of jiggly. It's more kind of, randomized, smooth perturbation. And all of these are using exactly the same shader. The only difference is which texture we swap out, right? So this looks pretty lasery. This looks a little Ghostbusters. And this is yet another texture, right? Getting that effect. Right. So how is the shader for this different than what we did? Well, it looks like this. It's not very different. I have, okay, here's me getting the scrolling UV coordinates. And this seems like it's a lot neater, right? But the truth is that I'm hiding some of the complexity in here. When you have a big mess on your page, a really good way to clean this up is to take some of it and make a new node out of it, right? So that's what I did. I said, okay, I know all this distortion, the perturbation addition to the UV stuff. This is a little bit complicated. So what I did is I took it all and I created this new node called distortion, right? And so I could scale it, I could affect the speed, I could play with some of the noise, right? It all went in there. I have this distortion strength, which, feeds into that. And if I double click into this, we get, okay, here's the actual distortion part. So I need to dock that. Can you dock, please? No? Can you full screen? How about with this? Okay. And you can see, yeah, this is doing some stuff with time. It it does the scaling stuff a little bit differently from what we did in ours, but well, I don't really want to take that detour right now. It just suffice to say, it basically does the same thing, getting the scrolled texture coordinate. I'm perturbing it here though by saying, hey, take my UV coordinates and get a value of noise, this noise value. But I get a separate noise horizontally than I do vertically, right? So I mess with some numbers here so that they're not the same. And once I get those noise values, right, I bring those back in. They get added together, and here they're getting remapped the same way, right? So remap, this default's -1 to 0.1, and then out it goes. So let's say you wanted to do this for yourself, right? You're kind of getting scared because this is getting out of control in your own shader, and it's not hard for that to happen. To make sure you have a grip on this, right? Maybe some of this gets you're like, whoa, I barely have a grip on all this. I don't like this whole perturb UV coordinate hackery that we're doing in here. What you could do is you select all this, and instead of making a group, right click and you say convert to subgraph. All right, so I'll click that. This is going to save just the stuff we selected as a new shader. I guess I'll save it. I'll say this is perturb V. That's fine, right? And now all of that nonsense gets hidden inside of that, that little node right there. There we go. Right. So much nicer. At least we corralled the mess into another separate shader. And that's pretty much all I wanted to show you guys for tonight. If you'd like, I can take everything in this project and put it up on Canvas as a Unity package for you guys to play with and check out at your leisure. Okay, cool. I am going to open up the breakout rooms for anybody that wants to keep working. And if you guys want to go, that's fine too. Breakout rooms.
Thank you, Professor D. Have a good weekend.
Yeah, you too, Jason.
Bye.
See you guys.
See ya.
Thank you very much, Professor. Really appreciate it.
Yeah, you're welcome. Good night, Earl.
Good night.